That is an insect.
Actually, we might need to get a pass, but like most people do it's like
Thanks, Troy. I'm glad I get a pass.
I'm ready for
Oh no. Okay, here are the standard errors for two samples. Just like before, you're going to notice that with proportions, you have a different one when you're using a confidence interval as opposed to a hypothesis test. They're slightly different. I guess this is the nice thing about doing a test for a mean, is that it's the same standard error regardless of hypothesis test or confidence intervals. So we'll just pause here for a minute if you want to write that down.
I have a really good question. Start. So, which test do we use for the calculator, and when and where do we use it? Well, that's a huge question.
Yeah, it really is.
Holy fuck.
Yeah.
That's a lot of questions.
It really depends on the context of the question. So that's how come we're getting in the habit of asking those three things. Like, are we talking about a test? Are we talking about? Are we trying to estimate? Are we talking about means? Are we talking about proportions? Do we have one sample or do we have two samples? Those three questions are meant to guide you to which is the correct test to use in the calculator and which test to use, period, really. Did we kill that second pizza, the third pizza? Did we kill the third pizza?
I can if you want.
Yeah, okay. Okay. Close it so it stays a little warm. Okay, since we have that, let's go ahead to chapter 10. Let's take a look at these free responses.
And it would be the same if it was a sigma for the means.
Yeah, I don't think you would ever use a z-test for means with two samples. It's just too many things to keep track of at that point.
All right.
Yeah. Yeah. Sure. Okay, so for response one, we have it's believed that the average amount of money spent per. I need my ruler again. I can't read. It's so bad. How did they even hire me at this school?
Why aren't you gonna watch JoJo?
These ones weren't that bad. Sometimes you go to them, especially the ones that are like 4 days long. I guess those are meant more for beginning teachers, but some of those are.
What are 4 days long?
Like they have conferences for AP teachers that are 4 days on the same topic.
Sounds like a bad deal.
As a beginning teacher, it's not bad. Yeah.
But then once you already kind of know.
Yeah, it's a little bit. Okay, so it's believed that the average amount of money spent per U.S. household per week for food is $98, with a standard deviation of $10. We have a random sample of 100 households in a certain affluent community, and they yield a mean food budget of $100. Wow. We want to test the hypothesis that the mean weekly food budget for all households in this community is higher than the national average. So does the affluent neighborhood spend more, perform a significance test at the 5% level? So this is Chapter 10 FRQs. Okay, so the first thing is def and hype. Okay. So we're not using definitions anymore, we're just using mu's. So subscript for my mu this time is affluent. That should be fine. I'm sorry, I forgot. Null hypothesis. I don't know what just happened there. Mu affluent is equal to 98 because we want to show that it's different than the, no, that it's more than the national average. So mu affluent is 98 as opposed to greater than 98 in this case, yeah. Mu affluent.
And never put units. You don't really have
Yeah,
to.
you don't have to put units.
That's awesome.
It's greater than 98. Not until the very end.
Okay.
Just for a quick question, are you recording this?
Yeah.
Can be famous.
Yeah. Okay, what's next is going to be our conditions and our confidence, our sampling distribution. So it's the same deal. We know that we're going to need to know the standard error. From that thing we just computed, the standard error is going to be s squared over the s over square root of n. So we are given 10 over the square root of, how many households do we have? 100? That's a big community, geez. We get one. Okay. What's next? We need to have our sampling distribution. Is approximately normal with a mean of 98. That always comes from the null hypothesis. Standard deviation of 1. Conditions. Condition 1 has to do with normal, or not normal, randomness. Do we have a random sample or do we have a random assignment?
Yeah,
Okay, so we are told random sample. That's good. Number 2 has to do with normal. How do I know that this sampling distribution is normal? Is the population normal? Where does it say the population is normal? It doesn't, but it does say that the sample size is big, right? Okay, so the sample size n equals 100. Please write down the sample size, don't just say greater than 30. N equals 100, which is greater than 30, so the central limit theorem.
And if it weren't greater than 30, what would we say?
You would have to look at the other two options, which would be a normal population or the box plot of the sample. In the absence of either of those, in the absence of all three of those things, that's when you would assume.
Okay.
Okay, number 3, we're going to calculate calculations. This is when our friend the calculator comes in. Stat, we already went through this. It's a test, and it's a, now is this a z-test or a t-test?
A t-test.
Do we have the standard deviation of the sample?
Yes.
And
That's from the sample?
no, that's from the
That's from the population. It is a z-test. Okay. So it's a z-test. Mu naught is 98. Standard deviation is 1. X bar is 100. Out of 100 households, these numbers are nice and easy. Okay. Oh, I'm sorry. Is our alternative hypothesis is that not equal to, less than 198, or greater than 98? Greater than 98. Good. Last, calculate. Oh, look at that p-value. Jeez. Times 10 to the negative 89.
At what point does it just say 0?
I really don't. I would imagine 10 to the negative 89 would be 0.
Well, yeah, but when does the calculator?
I would have thought it would have given me 0 at 10 to the negative 89. Okay, so we have a 1 sample, is that right? Z-test for mean. We have the test statistic. Z equals 20. Don't just say 20, you do have to say it's a Z or a T. P-value, that's equal to, yeah, I'm just going to put a 0 there.
Don't do that on the test, though.
You could, if it's 10 to the negative 89, yeah, put 0. You could put 0. If it makes you uncomfortable, put approximately equal to 0, but no one is going to fault you if you put 0. I'm not sure.
Like 100 to 98, like the mean is not that different from the sample. Like the mean of the population, the sample is pretty similar.
Well, what was our standard error?
1. So that's 2 standard deviations.
2 standard deviations.
That's correct.
Well, then we should get 2. Shouldn't we get 2 then?
I don't know.
Oh.
It's 10, not 10.
This should be 10 here. That's why. There it is.
That should be 10.
It should be 10, yeah. That's not standard error there. That's population standard deviation.
Oh, they calculate the standard error.
Yeah, they calculate the standard error for you.
Otherwise, they wouldn't need it.
I knew something was up, Mr.
You did.
Do you need to write down the standard error then?
Yes, you do need to write down. For me, you need to write down standard error. Okay, so that makes it a little bit better. Z is 2. And we get 0.0227, 0.0228. Do we reject or do we fail to reject? Reject H not. And then now we get to our conclusion. How do we see? How do we do our p value? Where's my script? Here we go. P value, the probability of getting a result as extreme or more extreme than x bar equals 100. What the heck just happened? Is about if mu equals 98. Thank you. Grazie. Same thing. In Italian, it's the same thing, isn't it? Is about 0.0228. We rejected, right? So at the, did we get a significance level? What is our significance? At the 0.05 level of significance, there is sufficient evidence to support the average food budget in the affluent community is greater than 98. That doesn't sound like a big food budget, by the way. $98 a week?
Sounds crazy.
I think I spend more than $98 a week.
Some nice-
Okay. Sounds good. Let's look at free response number 2. Yeah.
Don't we usually put the if u equals 98 first?
You can.
Okay.
Yeah.
That's not really.
Can you explain again why we use the z-test?
We used a z-test because that standard deviation came from the population and not from the sample.
No, it means well.
Okay, yeah, I got confused.
For the p-value, we don't have to write what we were before, where it was like p of z is greater than that. We can just write the number.
My gosh, we should be writing that down.
What?
Okay.
Yeah, man.
Probability of
Thanks.
No, I'm sorry. I was thinking of something else.
Okay.
We should be writing 0.0228 is less than 0.05.
Okay, but we don't have to write p-value equals p of z.
No, I think we're going to have to start doing away with that.
That's good.
somewhere in the problem, do we just state that alpha is 0.05?
It's stated for us, and we're putting it right here anyways, 0.05. It's also here, 5% level of significance.
If you say like it's a one sample z-test, doesn't that already mean it's with a mean dividing rate for mean?
Just to be complete.
How can it be a
Like,
one
doesn't
sample
sample
z?
automatically mean that it's a mean, like it's not a proportion, so it has to be a mean.
For a z-test, it could be for a proportion.
No, but like, you can have a
You
sample.
didn't write that it's for a proportion. Like if it was for a proportion, I'd write a one proportion z-test.
Okay, but I mean, we're talking about not just this school, we're talking about everybody's taking stats. So while I might know what you mean, is the person reading your tests in Kansas City, is he going to know what you mean? Is she going to know what you mean? And that's where they grade them. This I learned.
They grade all right through
You know, Kansas City doesn't sound like a bad place to go.
That's where Charlie Parker's from.
Yeah, exactly. Good food, good music. What more do you need? Kansas City Jazz, man. That's great. Where are we? Free response 2. Okay, I'm fearing that we're going to run out of time. So after free response 2 in chapter 10, we're going to scooch over to chapter 11. And then if we have extra time, we'll go on to free response 3 in chapter 10, okay? So when the antihistamine Seldane was first introduced, it was heavily promoted because it didn't cause drowsiness, unlike other antihistamines. A portion of the prescription information for the drug taken from the advertisement, adverse effects, blah blah, Seldane, N equals 781, is a proportion of drowsiness while using Seldane greater than the proportion of patients reporting drowsiness using placebo. Carry out a significance test for a conclusion. Correct me if I'm wrong, but this looks like 2 samples.
Yeah, it does.
Yeah, so it looks like it's more correct to use a 2-sample test here, right?
Even for chapter 10.
Yeah, I don't know why this is in chapter 10. This should be a 2-sample test. Is that fair for us to do, or should we do this as a 1-sample test?
It doesn't use a 2-sample.
Yeah, I know it doesn't use a 2-sample. But should we do this as 1 sample, or should we do this as 2 samples?
If we're going to do this as a 2-sample, can we just go to chapter 11 to do
All right, so let's just do this as 1 sample, okay? Okay, so let's This sounds like a two-sample test. But let's use P equals 0.081 as our population proportion. Okay, so that's what we're going to do. We're saying the population proportion is 0.081. That's what we're going to do. Mhm. That is from the box.
The placebo.
It's 8.
Oh.
8.1%, yeah. Why would you want it to be greater than the placebo? Wouldn't you want it to be less than the placebo?
Maybe they want to prove that it's bad.
Okay. Okay, so let's do this first one, def and hype. Okay, so hypothesis is proportion. Null hypothesis would be the proportion of people with drowsiness is equal to 0.081. Alternatively, we're saying that the proportion of drowsiness.
Would we say Seldane? Would we mention Seldane?
Yeah, we might make that Seldane instead. Seldane or drowsy. I'm fine either way. What do you want, Seldane or drowsy?
What?
It's already drowsy, so just leave
How
it.
you don't write down.
Okay. So the proportion drowsy we're saying is going to be greater. Yeah, is that greater than 0.081? One of the problems with this test or this question is I know a lot of people are tempted to put the wrong value for P naught. Okay, that does say 9%, and that is 0.09.
That's P.
That does say 8.1%. That is 0.081. So you got to be on the lookout for that. Do we need to do anything else here? I don't think we do, right? Next one. Sampling distribution. Let's compute our standard error. And that's going to be equal to the square root of 0.081 multiplied by 0.919. No,
Yeah, that's right.
0.919 divided by 781. That's my standard error. Zero zero 0.0098.
0.919.
Hmm? Yeah, it doesn't look as nice on this as it would on the calculator. Okay, so we have the sampling distribution. Approximately
One sample proportion.
normal with a mean of 0.081 and a standard error of 0.0098. How can we make this claim? Well, first thing is that we have to have an unbiased estimator. So do we have a random sample? It does say clinical trial, right? Would it be fair if I said clinical trial or told clinical trial? Did I misspell? Damn it. So that means random sample. It probably means random sample, right, if it's a clinical trial, unless it's a bad clinic. Number 2, how do I know that this is a normal distribution? Well, what's NP? .081 times 781.
63.
63, that's greater than 10. We also have N1 minus P. That's equal to 0.919 multiplied by 781. That's equal to, well, yeah, that's way over 10. So both of these are over 10. And that's the end of our sampling distribution. Boy, it's so much shorter than it used to be.
Do you miss the old procedures?
Was that?
Do you miss the old procedures?
A little bit.
Probably thorough.
Calculations. This is when we get to our calculator, right? Are we ready for the calculator? Let's get to the calculator. Sorry, we should get a name here. Do we have one sample or two samples? One sample. It's going to be t-test or a z-test?
Z-test.
Z-test for mean or for a proportion?
For proportion.
For a proportion, good. If you want to write the same thing as a calculator, it's one prop z-test. One prop z-test. P naught. That is from the null hypothesis. I saw multiple people put an 8.1 here, and the calculator threw up at them. So it's not 8.1, it's 0.081. 8.1%. The next one here would be the value of n times p. We calculated n times p as 63.2. In your calculator, you can't put 63.2, you have to put a whole number there. So what whole number are we closest to? 63. Sample size was 781. Our alternative hypothesis, not equal to 0.081, less than 0.081, or greater than 0.081? Greater? Let me see what we wrote. Yeah, we wrote greater. So 0.081, calculate. Here's our information. We get a z-score. Oh, look at that p-value. Something feels wrong about this.
Yeah, that's not right. What did you put into the
Let's take a look. Stat test. One prop z-test for mean. 0.081, 63 out of 781. Is that all right?
Why are you using 781 as opposed to 665?
665 is for the placebo.
Maybe the issue is that because we're treating the placebo as
the population.
population, but the population is smaller than the sample. That might have something to do.
Well, we were gonna probably, or it was more correct to use two samples.
Yeah. So that might be what's like. Is that possible?
Yeah.
Why are we using one proportion z-test instead of just the z-test?
One more time.
Why are we using the proportion z-test instead of just the
Because we're testing proportions.
That's the only reason.
I figured out what's wrong. We need our p-hat's 9%, right? So it's 9% of 781 that report drowsiness. Oh, 9%. Point times 781. You said 70.3. So I think that's just 70, right?
What is it?
70.
Oh, no, P is 0.188.
All right, that looks a little bit better. And I'm having a hard time explaining why that looks better. Well, for one thing, we do get the correct p hat. That p hat does look like 0.9. 0.09, sorry. All right, so let's calculate this. Standard error is equal to the square root of. Oh, we already did that. What am I doing? Oh, if this is standard error, that should be 0.09 then, right? 0.91. Okay, so here's our standard error. That's still not right. One more time.
It says 0.09 times 0.9.
Should be 0.91. Okay. Exact same number. Okay. What did we get for our test statistic? Z equals 0.884. We get a p-value 1884. .1884. Do we have an alpha level? Alpha level? It doesn't say anything, so let's assume that's 0.05. Do we? No, it's not smaller. That's greater, isn't it? Reject, fail to reject. Fail to reject H naught. Okay, conclusion. The probability, if P is equal to 0.81, the probability of getting a result as extreme or more extreme as P equals 0.09 is about 0.1884. We do not have sufficient evidence to support the proportion of patients using Seldane that experience drowsiness is greater. 0.081.
Why did we use that for standard error?
You're right, we shouldn't be using that for standard error. Because we're assuming the null hypothesis is true. That should be 8.1. Sorry, I'm really screwing you guys around here, aren't I? Is that right?
That's more than
Standard error.
Standard error needs to be computed with a null hypothesis. That's why.
And that goes for proportions. It goes in calculations, but for means, it goes in sampling distribution.
They should both be in calculations.
Oh, okay.
Yeah. It doesn't matter where you put it as long as you put it somewhere.
Okay.
No one's gonna mark you wrong because you put that standard error in the wrong place. Okay. Is there anything else here?
But we don't write that standard error down anywhere except for in the sampling
Yeah.
distribution.
We actually don't use it very much. It's just to keep us sharp with the standard errors. Okay. Any last things with free response number 2? Let's go to chapter 11 free response 1. Free response problem 1. Okay, gender differences in student needs and fears were examined in the article A Survey of Counseling Needs of Male and Female College Students, Journal of College, blah blah. Random samples of male and female students were selected from those attending a particular university. 234 males, 27.4% said they were concerned about the possibility of getting AIDS. Of the 568 female respondents, 42.7 responded they were concerned about getting AIDS. Is there sufficient evidence to conclude that the proportion of female students concerned about the possibility of getting AIDS is greater than the corresponding proportion of males? Well, the numbers do look pretty convincing, I would have to say. Let's check it.
It's really common multiple choice, and we're just running out of time. And we just put that the right answer, because we know what the right answer is.
I don't know what you want me to say to that. Do you want me to say that it's okay for you to skip things? No, it's not okay to skip things. What kind of question is that, really?
I was just asking what you think we should do if we're running out of time.
I mean, I can't tell you that you should be skipping things here, because you're not. Null hypothesis, that would be that the two proportions are different, right? So P, you want to put male or female first here?
Email.
Female? Minus P male equals 0. Alternatively, P female, bye-bye, P male. Now, which one was supposed to be greater? Female. So this should be greater than 0? Should be greater than 0, okay. And I think that's it, right? Let's do our sampling distribution. Am I crazy? We are supposed to put standard error here, aren't we?
Because otherwise you wouldn't really be able to.
Standard error is going to be equal to. Okay, so for proportions, we're going to need PC, right? PC, that's going to be equal to, let's see, total number of respondents who say yes. So that's 234 times 0.274. Plus 568 times 0.427 divided by 234 plus 568. So there's my PC 3824. Standard error is going to be equal to the square root. What is that? 0.3824. .2834 times 0.7166 divided by the first sample size, which is 234, plus,
It's 0.382.
what is it?
We switched the 2 and the
3824, and that means this is 6 and 7. Plus 0.3824 times 0.6176 divided by 568. Okay, so that's my standard error. Sampling distribution is approximately normal. Because 1, do we have random, is this either random selection or random sampling?
random samples of
Random samples, are they independent?
yes.
I would imagine we have males and females are different populations, so they are independent, right? So we are told random samples, and the populations of male and female are independent. 2. Oh gosh, here comes all the NPs and all that, right?
Yep.
Okay, what is this, NF, PF? That's equal to 568 multiplied by 427. That's equal to 264. NF 1 minus PF. That's equal to
304.
304. Okay, both of these are greater than 10. We'll do the same thing for the male population. NM PM. That's equal to 234 times 0.274. 64.11. That's greater than 10. And then we have NM 1 minus PM. That's equal to 1, I don't know.
169.884.
That's greater than 10. Great. That's everything for our sampling distribution. That's always the hardest part of these calculations. This is when we grab our calculator Okay, do we have one sample or two samples? Two sample t-test or z-test? T-test? Z-test for mean or proportion? Proportion, that's good. Stat test, 2-prop, z-test. Okay, this is going to be the same type of deal. We're going to have to round our numbers here to get the correct x1. So my first x1 is going to be... Wait, do we do females first or males first? We did females first. So we put females first. That's 42.7, 0.427,
264.
264? 264 out of 568. X2 is 27.4% of the males. There are 234 males. That's 64.1. You can't leave it at 64.1. You've got to make that a whole number. So that rounds to 64 out of the 234 males. And we said the proportion of females is greater than the proportion of males.
The proportion of males is greater
I have females are greater than the proportion of males.
Yeah.
Is that right?
Yeah.
Okay. Calculate. Yeah, that's 0. Just to double check to make sure we did this all correct. Is our P1 hat and our P2 hat correct? 427 for the females. 274 for the males. The males look good. Females, I don't know about that. We should probably check those females. That number doesn't look close, right? 264 doesn't look close to 427. Let's check it. Stat, test, 2 proportion z-test is number 6. 0.427 multiplied by 568. 243. Is that what we had before? Yeah, 264. Okay. Let's check now and see if that worked. 427. Yep, 427. 273. Yep, that's right. Alright, so this looks correct. How about that P hat? Is that the correct P hat? 3828. Yeah, close. Alright, let's take down our stuff, our test statistic. Z equals 4.087. Our p-value equals 4 zeros and a 2.
Could we write 0 for that?
Yeah, you could write 0. Let's make our decision. Our 0, what's our alpha level?
Doesn't say.
It doesn't say. So 0 is less than 0.05. Reject H naught. Conclusion. If the proportion of males, no, if PF minus PM is equal to 0, the probability of getting a result as extreme or more extreme than the one observed if is about 0. We, right? No, at the 0.05 level of significance, there is sufficient evidence to support the proportion of males, of females concerned about getting AIDS is greater than the proportion of males. I like that spelling, greater.
Mr. Furry, let me know right now. I refuse to do any call that does not deal with STDs.
It doesn't deal with what? That does not or does?
That's abbreviation for
I will-
standard deviation.
Only use
That is the funniest thing I've heard all day. So that's the abbreviation for standard deviation. Yes, sir.
So can I see what you currently calculated real quick?
Yeah, absolutely. Stat test 2 prop Z test for mean, no, for proportion. This is what I put in there. Okay, BB. PC, we used it just now. A test for 2 proportions. When it's a confidence interval for 2 proportions. Okay. If your results are statistically significant, find the 95% confidence interval for the difference in proportions between males and females. Were we statistically significant?
Yes.
Yes. Our results
What does that mean?
are significant. Let me finish writing this. Statistically significant. Okay. What that means is we rejected H naught.
Yes.
Oh, so it wasn't just like a vague we can't reject. Oh, okay.
Yeah. If you reject H naught, that means that your results are statistically significant.
We don't have to say that.
If you fail to reject the null hypothesis, your results are not statistically significant.
And you don't have to say that they're statistically
No.
significant. Unless it.
Statistically significant is shorthand for saying the null hypothesis is rejected. All right, let's get a 95% confidence interval. Confidence interval for the difference. Let's go to stat, test, 2 samples, 2 prop, Z interval. Oh, look at that. It saved our numbers for us. The only thing we need to change is a 95% confidence interval. What just happened? I think I pushed enter too many times.
0.08419.
Yeah, here we go. 2 prop Z interval. Here's our numbers. should be the same numbers that we used for the z-test. There we go.
And if we were asked this like follow up on a test, would we have to do the whole part 1 to do?
Depends on how it's phrased.
If it were phrased exactly like this.
Yeah, you should do the whole thing again.
Sucks.
Yeah.
Good times.
All right. Someone have these numbers written down somewhere? Do you have these numbers?
Just the interval.
Okay, you don't need the other ones. Okay, so I guess we should write up the whole thing. It's subtly different because we don't use PC anymore. So we're gonna get rid of PC. Again, subtly different. We don't need PC. We don't need the hype and def either anymore.
So there's no part 1.
Yeah, there's no part 1 because there's nothing. We're not defining anything anymore. So our sampling distribution standard error is going to be equal to. Now instead of using PC, we're going to be using the actual measurements, which was 274 and 726. And then over here, we're going to be using, what was that? 42.7, which means this is now 573. Slightly different. 358 as opposed to 378. Wow. Slightly different. Okay. Sampling distribution is still approximately normal for the exact same reasons. This is one where you might be able to say, let's see above. For the sampling distribution being approximately normal. What did we get for our sampling, for our confidence interval? 0.8419.
And then 0.2244.
Like that?
Yeah.
Okay.
What would the hypothesis be if we had to say it for this problem?
For part B, there's no hypothesis in part B. It's not a hypothesis test.
Do the whole thing again. Why did we just do all of that again? Or do we just
Well, the idea here was if you were asked to construct a confidence interval, this is how you would construct a confidence interval.
So
For the sample distribution, is it 0?
No, it's not. You're right. Thank you.
So for
Um,
confidence intervals,
So we have to do this. It's 4.427 minus 0.274, which is 0.2. I don't know. Can you please? 0.427. 0.153. 0.153.
so for confidence intervals,
Hmm?
we no longer have to. What do we put for part 1?
You don't. There's nothing to do.
Oh, that's so.
There's nothing to do in part 1 anymore. You could just write down the information that you know. Technically. Okay, are we okay with this? We should probably write a good conclusion while we're here. There's no more p-value. Okay. I'm 95% confident that the population proportion of the population difference of proportions between females and males who are concerned about getting AIDS is between 0.0841 and 0.2244. If this survey were conducted many times, then about 95% of the resulting confidence intervals would contain the true proportion. Yeah.
For the intervals, should we put like PF minus PM is, or can you just put that?
Just put that. Let's try and make this. Matt, did you have a question?
Yeah. So on the internet, it said that it's in between
0.08.
0.0818. Yeah, I'm not sure why.
so does it matter?
Yeah, I'm not sure why. Okay, that was just problem one. That was like two problems though. And we actually are out of time. Oh my god, look at number two.
Yeah, so can you make a promise that that will not...
He's giving us 3 of these on Friday.
Yeah.
Number 2 is actually
Like 15.
Yeah. Okay.
but like, isn't don't we want like 3 of number 2?